everybody, and welcome to another episode of the Elixir Mix podcast. This week on our panel, we have Eric Berry.
Hey!
Mark Erikson.
Hello.
I'm Charles Max Wood from devchat.tv, and this week we're talking to Julian Fahrer.
Hey guys, how's it going?
It's going all right.
So good.
We had a conversation a little bit ago and talked about Docker, and this was the first show that we could fit you on. I've heard a lot of people talking about Docker, and so I thought maybe we could do a show on it, even though it's not specifically an Elixir topic.
Yeah, definitely a hot topic right now.
Yeah. Do you want to give us just a brief introduction to what it is and maybe how you've seen people using it with Erlang or Elixir?
Absolutely. Docker is a container platform. You can imagine it to be a set of tools, services, and practices that help you to develop, ship, and run your applications using software container technology. And a software container is, I think, best described to be similar to a virtual machine. It is something that helps you to run multiple applications on the same machine, but you can run them in isolation. And classically, a virtual machine, and most people know them, they achieve isolation on the hardware level. That means that they slice your hardware into pieces, and then they assign some of those slices to a virtual machine. You install an operating system. The operating system boots its kernel. You have all the user space tools. You install the libraries you need, the application you need, and then you run it. With containers, on the other hand, you basically just start another process on an operating system. And this process uses some features of the operating system's kernel so that the process runs in isolation. That means it can have its own file system, its own networking stack, own process tree, own users, etc. Does that make sense?
Mm-hmm.
So the cool thing about containers is that they're much more lightweight than virtual machines. One thing is the disk size. A virtual machine, modern Linux distribution, you probably need a few gigabytes. A container image, the thing that runs the container, the underlying template, so to speak, can be just a few kilobytes or megabytes in size, depending on what you're shipping it with. There's no boot process. The container just shares the operating system's kernel. That means it just starts instantly. And there's obviously less resources that are required by the running process. There's no underlying operating system that needs to run and consumes resources. It's just another process on top of your operating system.
I think that's a really concise explanation of what it is. One thing that I really want to get to pretty early, though, is I have two ways of putting this question. One is what's in it for me, and the other one is, so who cares, right? So in other words, what's the applicability for me? What problems does Docker solve for a developer like me?
Great question. And I honestly have been abandoning Docker for quite a while until it clicked. And I think the point where it really clicked for me is when I joined a new company and they had this crazy application that was split out in 2 gigantic monoliths and a couple microservices and like tons of Redis and Solr and other services. And I wanted to do some work at home on the weekend, and I just couldn't get the application to run. The setup taking hours, and Postgres needed to be configured in a very specific way. And it was just horrible to get this thing up and running, even on just a new developer machine. And I guess this is where it clicked. It's like, oh, this is where people use containers, and they have a file where they can just describe all the dependencies, be it a microservice, be it something like a data store, a database. And Docker can just start all those services for you, connect them with each other, and they can talk to each other. There's no installation required. You don't have to run a specific version of your operating system. You don't even have to run Linux or Windows or wherever your application runs on. It just runs inside a container, and you're good to go.
I will say I had a similar experience. I recently changed jobs, and coming into this position, I have a system with it's 9 services, 3 different database types, like Mongo, MySQL, Postgres, plus Redis as a 4th. It's like these complex systems, and to get it all up and running, it's like it was easier to set up a Docker Compose, where I could just say, Docker Compose up and bring up all the separate containers where they're linked up to each other. So that really helped solve the pain point for me, just kind of like what you were describing there.
Yeah, totally.
One other thing I just want to throw on is that Docker works pretty much out of the box with Windows, Mac, and Linux. So if you want a Docker container and you want to hand it off to somebody else, it works across all three platforms. You don't have to do any funny stuff to get it to go.
Yeah, true. It's really great for sharing applications and making sure that it runs wherever you want to run it. You're kind of abstracting the underlying operating system and tools away from the actual application. It's just packaged and shipped as one big thing.
So I will say that there are two primary different ways that people use Docker, and I'd be curious to hear your thoughts on this. One is obviously there are benefits for deploying your system using Docker. But there's also the whole, like what we were just talking about, like kind of the developer story of I'm just using this locally to run my system and develop code. How do you usually use Docker, and what's that like for you?
I would say I would mostly use it in the development workflow and on CI/CD. That means when I start a new project, I started right away using Docker containers. And when we ship it, it just depends. If it's a small application and I'm the one in control, I usually run it inside a container in production. But there's also massive applications that have been, in use for many, many years, and that just have certain expectations and certain requirements that might not necessarily meet the idea of containers. So it might make sense to use Docker for development for those applications, but you just run them on a classical virtual machine or on bare metal in production. And I also seen other people that go the other way. They write their Elixir, Java, Ruby applications locally on their machines, but the DevOps team does not want to invest in, rolling out a bunch of virtual machines, installing the dependencies for the application, taking care of the dependencies. So what they do is they just wrap the application inside a Docker container and then ship that to production.
Great.
I've been doing a little bit of work with Discourse over the past year, just using their so they're an open source platform for forums. I think we've all probably used it. And so I've been doing some work for them a little bit, and they work strictly via Docker. So when you check out their platform, you check out the repo, they expect you to use Docker for development. And I'm seeing that that's actually a really good way to go. We have CodeFund, which is an open source platform for, it's an ad platform for developers. But we wanted to make that Dockerized as well. So if anybody needs to check it out, they don't need to set up their full environment or anything. They could just say, okay, here's the project. Let's, Docker console up, and then you got it running to be able to work. A huge tool for open source. Are you seeing that the projects are more and more going to that, where they're saying, okay, if you want to check this out and run it and work on it, here's the Docker?
I believe so, yes. I've stumbled across a bunch of open source projects lately, and I wanted to test them out, and they basically all provided a Docker image and a compose file that spins up the whole application and its dependencies. And yeah, it's great. Makes the whole thing very easy.
I've been using it lately to be able to work with something where I'm trying to split up Phoenix. So I have an application that I'm building that it's just a test application. I'm trying to make it so that I can have a front end and back end separated experience, similar to how Rails has their Rails API mode. And you can build right into it the front end framework. So I haven't seen anything in the Phoenix world that really allows that very well. So my attempt has been to be able to split up the application into essentially two applications and have it all run through a Docker. So I've got a front end folder, a back end folder. The back end has my Phoenix app. The front end has my Nuxt app. Each one of those has a Docker file with a Docker compose in the parent folder. It's been somewhat frustrating to get them working back and forth, but I think once that's working, that like I can pre-package that whole thing as one Docker container and deploy it, right? And that'll have both applications set up ready to communicate with each other. Does that sound right?
Sounds about right. I'm not too familiar with Nuxt. I think the basic idea behind containers is that you run things in isolation. So you would probably have one container for the backend and another container for the front end. Those might be shipped as a single container image. Maybe some background here. A container image is a portable and executable package that wraps an application and all the application's dependencies. That means that the package contains everything that the application needs to run, and you can just move it wherever you want. And when you run it or execute this package, you get a container. That means you could ship one container with the front end and back end packaged into it, and then spin up two containers, one providing, maybe Nginx to serve the JavaScript and HTML files, another container providing the API endpoints.
I've actually seen some of this done. So we have an Angular podcast, and John Papa has some tutorials on basically how to put your build system together in Docker. And so you write your Angular in TypeScript, and then you have a Docker container that spins up, runs Webpack, builds your thingy, or your application, I should say, not your thingy, but it builds your application, and then it basically deploys as its own application in its own Docker container and serves the static assets that way.
And some people don't even necessarily ship the container with the compiled JavaScript files to production. They just use Docker as part of the build pipeline. Mm-hmm. And once it is built, they just extract the compiled files and move them somewhere else, be it S3 or wherever you want to put them. So there's definitely a lot of interesting use cases for Docker and containers.
Yeah, I actually explored using Docker to build a Phoenix release. With Elixir, you can create a release file, which is like compiled, where it has the runtime dependencies for the Erlang beam and everything compiled into it. But it needs to be created for the environment that's going to run on. And so I can create it so it'll be ready to run on in a Linux server where someone with Mac could build it that way. And then had the Docker container export the built artifact. But I ended up finding that maybe that wasn't the best way to do it, but it was fun and it worked. And I was just impressed that Docker is really flexible in that way, where I can actually use it in a lot of different ways.
Interesting. What were the points where you thought maybe this is not the right way, and what would you have done differently?
Part of the question for me came down to the value of deploying a release if you're doing a Docker container. And obviously, there are still some benefits, like one of the applications that we have has some very specific libraries that have to be installed that are only available on CentOS. And so a Docker container works really well for packaging that up. But there are other situations where it's like, well, if it's a standard kind of Ubuntu or Alpine Linux that I'm running in, then some of the benefits of releases are I can do hot code upgrades. And I'm not going to be doing that if I'm using Docker, probably.
Probably not, yeah. It's a little bit against the idea behind Docker and containers.
Right.
Yeah, but that's fair. I guess you did a release with, I think it's called Distillery.
Yeah. Yep.
I'm also not sure how that fits into the whole Docker and container worlds. If you later run this release inside a container, it probably makes sense to just ship the whole application and do not create a release and just run it in place with mix Phoenix server or whatever.
So I kind of want to get into some of the basics of Docker. And first of all, basically, if I want to get started, it's like, okay, you've convinced me. I get all of this sandboxing. It doesn't mess with my core machine. It doesn't mess with the other machines. Sounds like the perfect solution for me. How do I get a Docker?
You go to docker.com, you click download, you select your operating system. It's super easy. They got packages for all the major Linux distributions. They got installers for Windows and Mac OS. An important part here is that there are no containers for Mac OS. There are containers for Windows, but let's focus on the Linux world for a minute here. What Docker for Windows and Docker for Mac do is that they set up a virtual machine on your host operating system, so the macOS machine or the Windows machine. And then inside this virtual machine, they run a Linux. And Linux inside this machine runs the Docker engine, the Docker daemon, the server part of Docker. And a Docker client is installed on your host operating system, your host machine. And it can just connect to the Docker engine that runs inside this virtual machine. So for you as a user, it doesn't matter which operating system you're on. It's totally transparent, but your containers will always run on Linux.
That makes sense. And then how do I set up a container?
There is something called a Docker file. And a Docker file describes how a container image is built step by step. You say, I want to use image X as a base image. That means copy all the files into my image. This could be, for example, Ubuntu, or this could be a pre-built image using Erlang and Elixir or Ruby or whatever it is. And then you can add additional instructions saying install this system library with apt-get install system library name. Or you copy files from A to B, you copy source code from your local machine into the image, you run a instruction to compile the source code into machine code or bytecode or whatever you want to compile it in, etc. So you get one file that describes all the steps that are necessary to get your application up and running. You then use the Docker client to build the image. And once you build the image, you can start a container based on the image with Docker container run. Another very easy way is to just do a hello world. You download Docker, you install it, and you type Docker container run hello world. What this does is it reaches out to a so-called image registry. It downloads an image that is called hello world, and then it executes this image. So it creates a container based on the image, and you get a hello world output, basically.
Nice. Now, it sounds a little bit complicated, and I just kind of want to simplify some of the things that you talked about here. So one is you talked about container registries, and basically those are images for your containers. And so you can go pull one down and set your database username and password, and more or less be done setting up your database. And similarly, if you want to use Ubuntu and you need some custom steps, you put those in your Docker file, and it's relatively straightforward to get something that'll run your app. And so, a lot of people get a little bit overwhelmed with the idea, okay, Docker and Dockerfile, and I've heard all these other ideas. And when it comes right down to it, it's a reasonably simple step to get something that is pretty uniform and you can pass around to other people and get the same thing everywhere.
Absolutely. Sorry for describing it too complicated. I guess that is the German in me coming out, trying to be too precise.
I don't think you got too complicated. It's just that there were a lot of topics that came up, and I just wanted to make sure people understand. If you want to go try this, there are some really simple steps you can take that make it really easy to get to. And yes. Julian explained a couple of those. And so, yeah, just go do the Hello World or go check out some of the images that are out there.
Yeah, and Docker is a really, really well-designed piece of technology. The command line utility is super easy. Everything is really, really straightforward. And getting something up and running it just takes minutes, maybe seconds if you have Docker pre-installed. It gets more complicated once you have more complicated use cases and try to do more, but simply getting an application or a database up and running is super easy, super fast.
What kind of gotchas have you seen with building out Elixir applications using Docker? Have you seen any gotchas that people have run into?
I think the biggest gotcha that people run into is they try to retrofit their applications into a container landscape, and they have certain expectations and certain opinions of how things should work. But it's a different paradigm, so things run differently. You need to forget some of the things you know and take a different approach. And I think that's across all platforms and all people I talk to, that's the biggest gotcha.
I actually ran into one the other day when I was building this example app, and I didn't understand how Docker worked exactly and how these pre-builds work versus building within the Docker container itself. So I kept running into this issue where it said that it couldn't compile. So I don't remember the issue exactly, but what ended up happening is I had to create a script that would run at the end of my Docker file that would essentially rebuild or build the dependencies within Phoenix on the Docker container itself, on that instance itself, because it required a Linux build instead of a Mac build. Does that sound familiar?
Yes. And I think what probably happened is that you were building things locally and then trying to run them inside a container, and you were just copying the whole build into the image.
That is exactly what I was doing.
Yeah. And I guess that's one of the expectations that people think like, oh, this should work like this. And then I just add this on top. But the maybe better approach would have been to only build it inside your Docker container, completely run the application in Docker, perform all your mix commands inside a Docker container, and there's actually nothing except for the files on your local machine. Does that make sense?
Mm-hmm. Yeah.
I have a bunch of questions, but I've been waiting for, the quiet for a minute, give everybody else a chance to talk. One other thing I'm hoping you can describe for people, and this is a term that I'm sure they've heard if they've looked into Docker for more than 10 minutes, is Kubernetes. What is Kubernetes?
Good question. Kubernetes is a more or less orchestration technology. It allows you to form a cluster of multiple machines, and then you can throw workloads against that cluster, and Kubernetes just figures out where to run it, make sure the application is healthy. If it's not healthy, it terminates a container, starts a container somewhere else. One of the big benefits of containers is you don't care where they run and how they are run. You just want them to be alive, more or less. And Kubernetes is one of the technologies that can help you to achieve that on a small or very, very big scale.
So if I have some microservices that support my application, I can deploy the entire cluster with Kubernetes instead of trying to spin up each Docker container individually and then make sure that they're all talking nicely to each other?
Correct. It's basically another layer of abstraction on top of it. It works simplified. It works in a way where you describe a desired state, saying, oh, I want these containers. I want X of them. I want them to be able to communicate with these other sets of containers. I want a data store here. I want the data to be persisted in this place. And then you give Kubernetes this configuration file, and Kubernetes starts working on creating and maintaining this desired state. So you're putting your whole infrastructure in code, and Kubernetes is working for you to figure out how it is run best and not going down.
So I know that one of the strengths of Elixir is the ability to cluster. I can have multiple nodes in an Elixir cluster, and they're aware of each other, and they can coordinate and pass work off. So with Kubernetes, what is a good way that you would suggest for people to organize that cluster?
Good question. I recently stumbled across a library, I think it's called libcluster, and they have a strategy that hooks into the Kubernetes API to get information about, which containers are running for this specific service. Give me all the IP addresses, and then you can use those IP addresses or this mechanism as your service discovery to form the cluster. But you can also use more traditional service discovery mechanisms like DNS or multicasts inside. It's just the flexibility that Kubernetes gives you just allows you to be a little bit more precise with service discovery, maybe faster, well, I guess I don't have any additional maybes here.
So one other thing that I'm wondering about, we've talked about using this in development, we've talked about using it in production. What do you do about continuous integration and maybe a staging setup?
Great question. And the cool thing about Docker and containers is that once you've written your Docker files, you've written a configuration that defines how this application is supposed to run and communicate with other services. You just use this configuration and these container images in CI/CD. You spin up the environment, you execute your test suite, and you're done. The only dependency that you will have on CI is basically Docker and maybe Docker Compose or Kubernetes, depending on what you're doing. And spinning up more environments, like a staging environment, is just as easy. You have all your configuration files. Maybe you want to add some additional configuration files to spin up more containers or an additional service that you don't need in development. But that's it. You just throw this configuration against Kubernetes or another container orchestrator or your local machine, and all your services are up and running and you can interact with them.
Now, when you're testing on CI/CD, it seems like there are two levels or layers of tests. So one would be something like running your unit tests, right? Where typically that's a script that's run on the machine. So does it actually reach into the container and say, run the tests? Or is this more focused on external testing, where you actually spin up a server and then you just throw your testing at the container from the outside and see what it gives you back?
I would say that both are valid ways. For the first one, where you run your unit tests, instead of saying mix test, you would say Docker compose app mix test. So it just tells Docker, run this command inside a specific container or service. And then there's the other side where you spin up an environment that you just mentioned and then test against this environment. You can do that. And the tests that are executed could either run locally on the CI/CD machine, or you also run this part of the tests in another container that just talks to your application that runs in a different set of containers. Does that make sense?
Mm-hmm.
Deploy more, pay less with DigitalOcean, the simplest all-in-one cloud computing platform for developers. Scale and run cloud applications faster and more efficiently with effortless administration tools to robust compute, flexible configurations, networking services, real-time alerts, and rapid provisioning, while enjoying industry-leading price to performance with a flat pricing structure across all global data center regions at any usage volume. Spend more time building better web apps and less time worrying about managing infrastructure with DigitalOcean. Build your next app on DigitalOcean. Get started with a free $100 credit at do.co/elixir.
Do you ever get tired of the word container?
Oh yeah, I use it so often. It's horrible.
Let's come up with a new word. How about code box?
Code box.
Works for me. We should establish that.
Happy wrapper.
Oh, that's a good one.
Yeah, Eric's been putting together sound clips for us.
That's awesome. I love it.
Yeah, I'm trying to get this stuff figured out. So far, not too good.
Hey, it's entertaining, right?
It is entertaining.
It is.
So is there anything more you'd like to cover, Julian?
I mean, I guess a personal interesting thing for me would be like talking about learning Docker, how to approach that. I don't know.
Yeah.
Scaling might be a thing that we could cover and why it becomes easy in containers. And then there's like a couple other cool things that containers make really easy, like logging and monitoring, just because there's an API that is provided by the container runtime to like basically solve this on a infrastructure level rather than an application.
Yeah, sounds good. So how do you approach learning it? I mean, we've asked a lot of questions, but yeah.
Good question. Funny story. My learning experience of Docker was pretty horrible. I did do what I mentioned earlier about trying to retrofit an application into a container landscape, and things just didn't make sense. And I like to learn on my own and just consume a ton of resources and trying to apply this in real life when I'm trying to solve a problem. And that just didn't work out for me at all. And I think the reason why it didn't work out for me at all was that Docker and containers are a somewhat different paradigm than classical infrastructure and applications. And I had all those assumptions, and trying to fit those assumptions into containers was just the wrong approach. And at some point I just stopped, went back, and try to forget everything I know and try to learn the basic concepts around containers, how they work, how they're meant to be used. And it turns out that a lot of the problems that I was trying to solve for, like logging, monitoring, service discovery, were actually not problems I had anymore because the underlying technology just took care of that for me. It also meant that I had to change a bunch of the application code in our use case and make this whole thing work in the container landscape. But yeah, the big takeaway for me was that learning Docker while you're trying to do something with it is pretty hard. A lot of the resources out there are really great in delivering what Docker can do and maybe give you a quick how-to, but the big thing that is missing is how you can actually apply this in real-life scenarios and make sure that it fits your use cases. And after being pretty annoyed with the experience, I decided to change this for other people. And I put out a whole course, learndocker.online, that takes you from the very beginning, covers all the basics, what containers are, how container images work, how they're meant to be used, best practices, and then take you step by step when writing your own code, deploying this code to production, implementing logging, monitoring, and other things, running your tests on CI, CD platforms, etc. So it's like really from the very basic all the way to the end. And that was the big thing I missed when I was learning Docker. It was just there was no red path that guided me through it. It was all just, here's a tutorial for how to use Docker with Rails or with Elixir and Phoenix. And it's just like, cool, but it only answers, 1% of all the questions I have and problems I need to figure out.
Right. We're also going to be doing a webinar. I should probably mention that. We're going to be doing a webinar on August 8th. That's a Wednesday. It'll be at about 11 in the morning. And Julian's going to be going through all of the stuff you need to know for learning Docker and using it with Elixir.
Yep. Looking forward to it.
Yeah, and I'll get the link into the show notes so that people can go sign up for that. But lots of stuff. And isn't there a coupon code for learndocker.online for Elixir Mix listeners?
There is. It's a long URL, so we're probably just going to put it in the show notes. You get $30 off. We're definitely going to keep it valid until after the webinar. And totally worth it. Check it out. We have hundreds of videos, quizzes, instructor access. You can directly talk to me if you have any questions. I'm always happy to help. And I guarantee an excellent learning experience.
Awesome.
Guaranteed.
What was that, Eric?
Guaranteed.
That's right. So I do want to ask a few more questions about logging and monitoring, because most of the applications that I've written, they log to the local file system, which would be inside the Docker container. So how do you make the logging, persist past the lifetime of the container?
Great question. The answer is you log to standard out and standard error instead of files. And the container runtime takes care of getting the logs and moving them somewhere for a more persistent storage. That could be somewhere in the cloud, locally to files, syslog, fluentd, whatever you want to use. So you basically take logging away from the application level and put it into the infrastructure level. So you can solve it in one place for all of your applications.
And monitoring, do you just build that into your container, or are there infrastructures that kind of connect to Kubernetes or wherever you're running your monitoring or your containers and do that for you?
Another good question. Another level of monitoring is more the application level, meaning it could be how many open database connections, how many requests per minute, how is the response time of your application. And there's different points of the infrastructure where you can integrate with that. For example, you might have something like a service mesh running inside of Kubernetes that takes care of allowing your microservices to communicate with each other. And you just get those types of monitoring aspects from the service mesh. Another thing I see people do is using something like Prometheus. Prometheus is a time series database, to simplify it. It's also an application that can grab statistics from other endpoints over HTTP and store them. So you basically, Prometheus talks to all your containers, gets the statistics they expose, stores them, and then you can create alerts, graphs, etc., based on this data. So instead of having it on a per machine basis, probably in a classical infrastructure, you have a central place where you monitor everything, and your containers and container runtime and the orchestration software all expose this information about containers, like CPU usage, memory usage, open files, whatever it is you want to know. I hope that was not too complicated of an expression.
No, it sounds really interesting. And then as far as deploying applications goes, if you're not using orchestration software, do you just pull down the container that was running and then spin up a new one? Is it that simple?
It's that's a legit way to do it. There's also more and more container as a service platforms coming out. I think Amazon now has Fargate or something like that. So instead of taking care of orchestration software and the underlying infrastructure, you just tell Amazon, look, here's my container image. I want to write 5 of these. Just do it for me. I don't want to take care of the hardware and the virtual machines and any other thing. I just want to interact with containers. Mm-hmm. And if you have a small application, there's also nothing wrong with manually installing Docker without any orchestration component on a virtual machine, maybe on like DigitalOcean, AWS, wherever you want to do it. Install Docker, pull the images, spin them up, and you're done. I do that fairly often for like small applications and playing around with stuff.
Yeah, one other place you can go, and I'm pretty sure that they still have the $200 credit when you sign up, is Microsoft Azure. And totally. One thing that's really interesting is that Docker is basically a first-class service for them. But if you're using Visual Studio Code and you use their Docker plugin for Visual Studio Code, it'll create the container for you. It'll help you manage the containers on your machine. And you pretty much can just click a button and it'll deploy it to Azure for you. And so if you want a seamless and really easy way to get started and kind of see how it works as far as running in the cloud and stuff, you can do all of that stuff. And like I said, when you sign up for the first time, you get a little bit of a credit there. So if you want to play with it and see how it works that way, that's another way to do it.
Yeah, it's a really good point. And I think we're going to see a lot in that direction with Microsoft buying GitHub. And I think they have big plans in that direction to just take your code and spin it up inside of containers automatically. GitLab has released some cool stuff where they automatically deploy to the Google Kubernetes engine. If you push code without you managing the infrastructure, they take care of that for you. So there's definitely a lot of great options out there.
Yeah, GitLab CI and CD also, or at least their CI engine is all Docker. So it'll spin up a Docker container, run whatever you told it to run in your gitlab.ci.yaml. And then it does all that too. So you may be using it without knowing it.
Totally, you're probably using containers in one way or the other, for sure.
Yeah. So one other thing I'm wondering about is, let's say that I have an application that I've deployed traditionally to a server. I've got it on DigitalOcean. It just runs up there on the server, and then I'm thinking, I kind of want to move this to Docker and run it that way. Is it really that difficult to move from one setup to the other?
No, not necessarily. I mean, every application is different, and it just depends on what it is and how familiar you are with the application, how familiar you are with containers. It's definitely doable, but I also run into applications that we've been trying to Dockerize for months now, and we're still not close in getting this into production. And we probably will never do that. It's by the time we would be ready, this application is probably obsolete anyway.
What's the hairiest setup you've tried to Dockerize?
Probably a gigantic Rails monolith with, the test suite runs about an hour, has 10,000 tests. It's an enormous amount of code and configuration, and everything is overly complicated, a little bit over-engineered. And we use Docker for development with that application, and that works kind of fine. But I don't think that we will try to Dockerize the production part of the application. That's too much effort, and the benefits we would get out of it would not be that enormous. In this use case, there's always depends on what your application is doing and how you're using it. But
what are some of the kind of things to look out for when you're wanting to say I've got this a legacy Rails monolith. It's not perhaps as hairy as the one you're describing, but I'd say, I'd really like to try and put this in Docker and get this something that can be easily deployed. What are some of the things I should be watching out for that I may have not been aware of that when I built the application that would make it, what am I looking for when I'm trying to put it into Docker? What are the common problems I might have?
So for development, I think one of the things that people need to be aware of is when you use Docker for Mac or Docker for Windows, and you're trying to sync your source code between your host operating system and the container to iterate on a problem when you're developing. That might be slow because Docker has to basically mount the file system of your host operating system into the virtual machine, and then from the virtual machine into the container. So there's just a lot of overhead going on. And if you have a bigger application, that's going to be slow. Like, instead of having a startup time of the application of 10 seconds, it might all of a sudden be a minute and a half or something. That's a big one. Another thing is that I think in development, a lot of applications just assume that the database and Redis and other things run on localhost. That's not true if you split them up into multiple containers, what you should be doing. So there might be a lot of configuration changes that are required or assumptions that need to change in the application. I see a lot of applications in development, like logging to files and then using something like Foreman to start multiple services and tailing the log files. That's a thing that's going to be different. It's just like things you don't need anymore. For example, things like Foreman or something that loads your .env file. Docker will take care of that for you. And another thing that might require some changes to your application is the idea that we mentioned it earlier, logs go to standard outs, not error. And you should configure your application using environment variables. That means instead of writing configuration files, store them in source code, or use a configuration management tool to write those configuration files, you want to use environment variables to define things like, this is the URL to connect to the database. This is the IP address of service X. This is how many processes you should fork. And you should extract all those things into environment variables, which is also defined in the 12-factor methodology, which is also, if you're getting into containers, that is definitely a manifest you should have a look at, 12factors.net, I think. It is, I think initially from Heroku, it describes good practices for developing modern web applications. And a lot of those best practices, like basically all of them, apply for containerized infrastructure. So definitely check them out if you are getting into containers.
Yeah, having recently added a Phoenix application to a Docker container where it was not created with that in mind during the creation of it, environment variables was the big thing that I kept hitting. That and the assumption that like configuration to say, if the mix environment is prod, then I'm going to use these different behaviors. I'm going to be looking at this hard-coded URL as a source to communicate with this other service. And that was a big gotcha for me.
Yes, that's another big one. The different application level environments. Docker is not necessarily meant to be used with those, and the idea is you just spin up different environments on different system using different set of configuration from the outside and not on the application level. It's just important to keep that in mind, though, and it doesn't mean that you should not use containers in combination with something that has application-level environments like Phoenix or Rails. It's still perfectly fine. It works. It's just like something to be aware of. How did the project end? Were you able to Dockerize everything and make it work?
Yes. So the first phase was getting it to work in a development environment, and that was just helping to identify all of the environment variables. We haven't gotten to the phase yet where it'll be part of the deployment strategy. I plan on using Kubernetes for that.
Nice. Do you have the feeling that it is beneficial in the development process?
I do. I really enjoy it. I think you end up with better code if you're kind of organizing all of the environment variables into one place, and you're making it easier to kind of look at the application from the outside as a new developer. And I think it's just, you end up with easier to maintain code too. Like part of that whole Docker and deployment strategy that I really like is the idea that you're taking the same build. So I can build a Docker container and I can take that through a test environment, then into a staging environment, and then into a prod environment, and it's the same build of the software. I'm not recompiling for each different environment. So in terms of QA, they have validated that this code is good code. Then I can move it into the next environment, kind of promote it to the next like staging environment. And the environment variables change to say, oh, talk to this database, you're talking to that external service. And then, but I'm still just working with the same container. And I've validated that container, and that's being promoted, and that's going on. And I just love that whole approach and kind of way of thinking about it.
Yeah, totally. That's one of the big benefits. It's like same environment everywhere. There's no runs on my machine or different sets of problems that arise when you deploy. It's like, you know how it's going to behave no matter where you run it.
Can I ask real quick on the environment variables? How do you maintain the secrets? Because don't the environment variables wind up in the Docker file?
Depending on how you solve it, you could definitely do that. But there's like not a good idea for obvious reasons. And there's
I was thinking.
There's a lot of solutions out there that help with those issues. If you're using Docker Swarm, which is the Docker homemade orchestration piece, you get something that is called Docker secrets, and they help you to define a secret, store it in a secure place, so it's never touching the disk unencrypted. It helps you with decrypting the secrets, delivering it to the container that needs access to the secret, and just places a file in memory inside the container, so the container can read the secret from a file. And it's totally transparent to the application. All it has to do is read the secret, or you can do that in a startup script and read the secret, put it into an environment variable, something like that. And there's other things like HashiCorp Vault. There's a ton of solutions for Kubernetes out there. The cool thing is like this whole container ecosystem, and Kubernetes gives you clear interfaces and APIs to deal with those kind of things. And you can just plug in a third-party tool and solve it on a infrastructure level again, just like monitoring or logging. And all your application does is it reads the secret. Done. It does not know where it comes from or how it gets there. It's totally transparent.
Makes sense. So one other question I have is, it seems like scaling happens on two different levels with traditional architecture. You either add more resources to the server you're already running on, or you find some way to balance across multiple machines. And it seems like in some ways your containers could, act in similar ways. You could have basically a load balancer container that, spreads the load out to multiple containers, or you could just have containers that have access to more resources. Do you have a preferred way of doing that? Or is there something else that Docker or Kubernetes gives you that makes that easy or easier?
Depends a little bit on your application and your actual requirements. Having a load balancer and spinning up more of them or more containers that run your application is probably the most common way. You can also assign more resources to a specific container, which might make sense if you're running something like a database management system or a data store and it just needs more RAM. Then that's an easy way. I forgot the other part of the question, to be honest. I think it was if Kubernetes has like some built-in solutions for that.
Yeah, if Kubernetes or Docker Swarm or any of those.
They definitely have integrated solutions that make scaling easier. One of the core ideas behind container is that they should be stateless. That means there's nothing in the container that you care about. And that makes scaling as a thing easy. If there's nothing in the container, if the container is ephemeral and stateless, you just add more containers if you need more resources. And you just remove containers if you need less resources. So scaling up and down both becomes very easy. And all the orchestrators, be it Docker Swarm, Kubernetes, or anything else that's out there, gives you the APIs and interfaces to spin up more containers or remove containers. And you can integrate that with the AWS load balancer and say like, oh, if I have that many requests, spin up more containers. Or you integrate it with your monitoring solution saying like, oh, if the response time for these endpoints is higher than 100 milliseconds, I might need more containers. So just create more for me.
Right.
And then your service discovery and load balancing mechanism discover those containers, sends traffic to them, and you're done.
That makes sense. If they're stateless, how do you run a database on them?
Well, people still say do not do that. It's like back, 10, 15 years ago when people said don't run your database in a virtual machine, and now everybody's doing it.
Mm-hmm.
One way of solving the problem with persistence or stateful applications is that you persist the data in a dedicated spot. This could be, for example, on AWS, Elastic Block Storage. This could be S3. This could be a specific machine where you run the container on, and you expose part of the hard disk and give it to the container to write to disk. There's a ton of solutions and a ton of vendors that do really crazy things. And I think we will see a lot of change and innovation in that department. I personally do run databases inside containers. I would maybe not do it if it's, crazy production database with terabytes of data, but for a small application, a side project, or maybe if you're just getting started, I think that's perfectly legit to do that. Just make sure you have backups and be aware that you know where your data is stored and what happens when your database goes down. Makes sense.
Well, I think I'm out of questions. You guys have any more questions?
No, you answered them all. And plus, if I don't have the answers, I know I can go to learndocker.online.
Yeah, absolutely. The best resource out there.
Yes.
Yeah, make sure you get that discount, folks. All right. Well, should we do picks then?
That sounds great.
All right. Mark, do you have some picks for us?
Sure. Recently, when I was working with Docker, setting up a development environment, I had the problem where I was dealing with user permissions. So like when you're doing a Phoenix and you're saying, mix, ecto, generate a new migration, that is a file that's being created by the Docker user inside the container. And that typically, by default, is root. So that would be putting a new file in my file system that was loaded in through a volume. It'd be putting it into my file system as an owner of root. So I didn't actually have permissions to modify the file. So the alternative is I'm doing chown or changing owner or different things. And I didn't like any of those solutions. I reached out to a friend and said, oh, you need to do it this way. And so I put together a gist that shows how I was able to resolve that problem. And really what it comes down to is when you're building the container, you're passing in to the container, what is my user ID of the user who's actually doing the development, and then changing to that user inside the container. So when a mix task creates a file or something, I'm still the owner. So it just kind of solves for me that who owns the files that are being created. And that happens with NPM packages when you're doing like an NPM install or even a compile. So I'm just going to share that gist.
Awesome. Eric, do you have some picks for us?
I have one pick, and I can't remember if I've shared it before. I apologize if I have. Every night, my wife and I go to bed and we watch TV, and if she's like, you guys or anybody else, she just falls asleep pretty quickly unless she has something going on. So for a long time, she would play with her phone and play those stupid coloring book games where you zoom in and you find the number and you the color, and then at the end, you've just created this insanely awesome pixel art just by pushing buttons. So I thought that was kind of neat. So what I decided to do was I went over to the local hobby store and bought. I went to Walmart and bought cross-stitching stuff. So we bought all this stuff to start doing like these cross-stitch art, and so we created it, and I drew out a design on there, and I said, here you go. So at night, it's so much fun. Like we're both doing it now. So Shay, really old people, we're sitting on our bed cross-stitching and needleworking while we're watching shows. I finished my first one 2 days ago. I'm pretty excited about it. So yeah, it's a lot of fun. And I read an article saying that there is a link between software developers and cross-stitching. I was looking for the link. I couldn't find it, but yeah. So there you go, cross-stitching.
Nice. I'm going to get you some crochet hooks for Christmas.
No. It has to be cross stitch. I crochet. I suck at it.
All right. I'm going to jump in here with a few picks. So I took a couple weeks off, and anyway, I really needed the time. I was super burned out, overstressed, blah, blah, blah. And anyway, I just took a little bit of time to work on some projects that I had that were like not pressing things that would not stress me out. And one of them, so I don't know if people have a good idea of how I spend my time, since I mostly do the podcasts and the processes for that. I do a little bit of coding for that, but most of it isn't. And so I spent a week just working on the coding on the systems for the podcasts. And that was really, really relaxing. So I really want to just encourage people to take a little bit of time to code for fun. I think a lot of times we get tied up in, I'm working on this for work, and then I go home and I work on open source, and none of it's really just kind of leisure coding. And so I just want to pick kind of that leisure coding. The other thing that we did last week is we had a big family reunion down by Zion National Park. Funny enough, we were a few miles from the entrance to Zion National Park, and we didn't actually go to Zion National Park, which is an amazing place, by the way. I've been there before. But we went out to Sand Hollow State Park, which is a big reservoir, and played around. Most of the time we just played games and spent time at the house we rented. And we just had a good time. And I went and had a nap whenever I wanted one. And, there were a bunch of adults around. So, if my 2-year-old went outside, there were people with her. And so I didn't have to worry about her that much, sometimes I was outside with her. But anyway, it was just relaxing. So I also just want to encourage people to get away. And I worry sometimes that we get so caught up in all the stuff that we're dealing with that we don't take time to just be human. So I just want to pick that as well. Just get away. Most of us work for companies that will give you vacation time. So take it. Go do something fun. One thing I have found, though, is I love taking my family to Disneyland, but that isn't relaxed time. It's different. And this was different, where we actually just, had downtime. So anyway, that was terrific. I also want to reiterate the webinar that Julie and I are going to put together in August. That's August 8th. I'm just going to put a URL out there, and then if you go to the URL, it will take you to the right place, because we have about a week before this goes live. So that gives me a day or two to get it together. But if you go to devchat.tv/elixir-docker, then that'll take you to the place where you can sign up for that webinar. And don't forget to use the code ElixirMix to get $30 off Julian's course, because I really feel like Docker is one of those technologies that the more we build web applications or services that service applications, it's just going to become one of those things that everybody at least needs to have a fundamental understanding of. So go check it out. Julian, do you have some picks for us?
I do. I don't think they're as great as your guys's, but let's see. One thing that I picked is the CNCF landscape. CNCF is the Cloud Native Computing Foundation, and they're involved in modern infrastructure, cloud native movement, containerized workloads, and they have this enormous map. I think it's maps these days, where they list all the vendors, platforms, tools, systems, utilities for various areas in a cloud native landscape. So this could be cloud providers. This could be tools for service discovery, load balancing, proxies. So if you want to know what's out there, what is hot, and what people are using, that landscape is really, really great. My go-to place if I have a problem and I don't know how to solve it with a containerized infrastructure.
Awesome.
Another pick I had is Indie Hackers. That is a community. I am a big fan of them. It's mostly solopreneurs or smaller companies, bootstrap companies that tell their story. It's a very inclusive community that helps each other. So if you're working on a side project and you're trying to get some tips, you're not sure how to monetize it or how to find the time to actually work on your project, check it out. It's a really, really great community. And the third one would be a book called The Ultramind Solution. I have to admit, I have not read the book myself, but my wife reads it currently and she talks about it every day. It is a very scientific approach of explaining why certain things that we consume on a daily basis or things we do are actually bad and slow down our brain, might be responsible for illnesses, sicknesses, depression, and so forth. And it gives you solutions on how to fix that. I am very much into optimizing my time, my brain, and what I'm doing. And there's some really, really great resources, tips on how to eat, how to take care of yourself, and how to make sure that you stay healthy and have a ultra mind. Great book.
Awesome. Now, if people want to find you online, or
people can absolutely find me online. One way is learndocker.online. You can also shoot me an email, julian@learndocker.online. You can follow me on Twitter. I'm JUFAHR. And I usually have at least a landing page with what I'm up to these days and where you can hear me talk next or on a podcast at codetales.io. It's like fairy tales, but for code.
Awesome. Very cool. Well, thank you for coming. This was a fun chat.
It was indeed. Thanks for having me. I really enjoyed this.
Yeah, thank you.
Yeah, thanks, Julian.
All right. We'll catch everyone next week.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.